To give you an understanding of the ammonia cycle in this room, when the compressors ramp up, they create a low pressure environment on this line. So they start creating suction on here. This is your low pressure line, and you can read the pressure that it's at there. The temperature of the ammonia gas going into the compressors is displayed here. That low temperature corresponds to this low pressure. You can reference a chart that will tell you what temperature you have for a given pressure of ammonia. The compressors take that ammonia that is coming in as a low pressure vapor, and you can see from the arrow it's flowing this way as the compressors suck in the ammonia at low pressure. They're compressing it and they're discharging it through here at high pressure as a vapor. So it comes in as a low pressure vapor and it exits as a high pressure vapor. This here is the temperature that it's being discharged at. So this is your discharge temperature, and that corresponds with your high pressure. So just as the suction temperature corresponds to your low pressure, the discharge corresponds with your high pressure. Once the ammonia, I should probably also mention, this here is your relief valve. If there was ever to be too much pressure in the compressors for some reason, this would release the ammonia through the relief line, and it would end up over in the corner of the room by going through this and into that water tank down there. That is a great way to have the ammonia contained in water in the event of a high pressure release through a relief valve. So back to the ammonia cycle, we've got the ammonia coming up here, along here, and it's flowing into here. This is the oil separator. What the oil separators do is they remove the oil from the ammonia and channel it back to the compressors. So the ammonia gets run through the oil separator, and as it goes through there, it feeds down into here. In here there's a little float. When there's enough ammonia, float goes up, the oil drains down and back into the compressor. That oil level in the compressor is seen here. What Ultimate Fabrication has done is they've designed this to maintain constant suction pressure, so the compressors are going to ramp up and ramp down. So the VFDs will change the speed the motor turns at, which changes your suction pressure or your low pressure, and by managing the low pressure they get really good oil separation, which means unlike our old plant, we're no longer going to be adding oil to the compressors all the time and draining it out of the chiller all the time like we used to. So because of this constant monitored suction pressure, you get good oil separation. That means the ammonia that's leaving the compressor's oil separators and heading out to the condenser has had pretty much all of the oil removed from it. Now, the high pressure, high temperature ammonia is coming along here, and it's next traveling to this Doucette, which is a domestic preheat for the hot water. So this blue box up here essentially acts as a desuperheater. This here can control whether the ammonia gets fed to the desette or bypasses it, and that's because if, say, your domestic hot water was already hot enough, you don't want to boil the water, so you need to bypass it and funnel it past the desette instead of through it. When it's running through the desette is essentially taking the superheat from the ammonia and it's transferring it to the domestic hot water. So that HX5 is a great way to take essentially free heat off the plant and heat the domestic hot water. Currently it's not hooked up, it'll be hooked up shortly. So after that, the ammonia is running along this pipe here. You can still see from our labels which way it's going, that it's still a high pressure, high temperature vapor. And then it's coming over here. In here we have the condenser. So the condenser is a plate and frame heat exchanger, and it's using glycol to remove heat from the ammonia. So the glycol's coming into the heat exchanger at a lower temperature, and it's leaving the heat exchanger at a higher temperature. That glycol gets cooled in a number of ways, which I'll explain later, but for now we're going to focus on the ammonia side. So the ammonia is coming in to this heat exchanger. This heat exchanger is plate and frame, meaning it's got a whole series of plates, and in those plates we've got alternating ammonia and glycol for a very efficient heat transfer. So as the ammonia gives its heat up to the glycol, the ammonia condenses and it goes from being a high pressure, high temperature vapor to a high pressure vapor and liquid. So in this tube here, this pipe can be carrying both liquid and vapor. This is flowing over here to HX4. So HX4, that heat exchanger, is an ammonia heat exchanger, and it effectively acts as a subcooler. So that's getting your ammonia to definitely be in a liquid state by the time it comes down out of the heat exchanger and flowing through here. So you can see here we had liquid and vapor. After it passes through this heat exchanger subcooler, you'll see it's only flowing out here as a liquid only. On these sight glasses in here you should see ammonia, and on here you should see ammonia. So the fact that it's dark tells you that it's got ammonia in it. If it didn't have any ammonia, it would be clear like this one. You can see the metal back there. That's because there's no ammonia liquid in this sight glass. The reason there's no ammonia in this sight glass is because this side over here is the suction side going to the compressors. So it'll be normal to see no liquid here, but to see liquid here, and you definitely want to see liquid here. And these are the two that you're checking on your building checks. The ammonia liquid is flowing out here to these. So there's two of these, and these are the electronically controlled expansion valves. So what they do is they modulate and control the amount of ammonia that's going in to these two heat exchangers. So HX1 and HX2 over there are both fed from this common ammonia supply with liquid ammonia, and these expansion valves are modulated in coordination with the compressors. So they are controlling the amount of ammonia that can go into these plate and frame heat exchangers with the brine. So as the ammonia goes through this heat exchanger, it's essentially boiled off using the heat from the brine. So the ammonia removes the heat from the brine, it picks up its heat as it's boiled off, and it gets pulled out through here and out through there on the other side. So you can see the two with the relief lines on it. So this here with the relief lines, and over there with the relief lines. Those are both the ammonia sides of these heat exchangers. And you can see the ammonia comes out here, and at this point it's coming out and it is a vapor. So you can see low pressure vapor, ammonia flowing this way out of these two heat exchangers, and that is what the compressors are drawing. So when the compressors turn on and the compressors are pulling the ammonia into them as low pressure vapor, that's where it's coming through. And that completes the loop for the ammonia part of the refrigeration process. In the next video, I'll cover the brine side and where the heat's going there.